Now, one of the things that's challenging about the integrals that you guys made as extension 2 students is that sometimes they look like you can't integrate them because they are 2 or more integrals masquerading as 1. Okay, so here's an example, right? Now, this doesn't look like it fits any of our nice, neat patterns, right? This certainly not the derivative of this, not even, well, it's sort of close, but it's not there, okay? So what am I going to do with this, right? Mitsu?
Maybe you would separate the x.
So I'm going to take the suggestion of seeing that I can split apart numerators, right? You can't just split apart denominators without doing partial fractions, which we'll look at tomorrow. But numerators, easy to deal with. So if I break this into half, like so, it becomes a little clearer that at least that right-hand part of the integrand, right? What is that? That's a standard form. That's sine inverse of x on 2, right? Because it's 2 squared minus x squared, so that's easy to deal with. The left-hand side, not that neat, but it's still, like, I can cope with it. If I rewrite it, because rephrasing the question, as you know, sometimes makes it so much more obvious. If I rewrite it like this, you can see, and you see what's going on here, this is a pretty standard case of reverse chain rule, because the derivative of the inside function is negative 2x, which is only off by a constant from what's on the outside. So that's basically going to be my f dash, yeah? So sometimes you'll see something, you know, it's kind of like that that picture of like 2 children sort of standing on, like one standing on the shoulder, then put a trench coat around. It's like, what is this thing walking around? It's like, it's not one thing. It's 2 things, and then they're very easy to deal with. So here are 2 examples, and they end up with logs once you work with them. Watch. This guy here looks like 1, right? It looks like a single integral. But if I play a little bit of algebra here, I can go through and I can actually carry out a division and separate things out. If I take away 1 and add 1, we saw this trick in some of our earlier questions, right? Then what you've got is a part of the numerator that I can simply remove, and it cancels, right? You've got this guy here, which is just going to become 1. And then you've got this guy, which becomes... This is a log of, and because we're in extension 2, it's the right time to say the absolute value of x minus 1, and there's my constant. Now, that's fine, and you should absolutely do it that sort of quick way if you can see it. However, I don't know about you, but I always found it a bit unsettling when people said to me, oh yeah, you just add 1 and subtract 1. I always find that a bit arbitrary, and it doesn't always work. It's not very systematic, right? Especially when you look at something like this. What are you going to do with that? Right? In this case, right, I've got a variety of choices, but being that the degree of the numerator is bigger than the degree of the denominator, it seems most straightforward to me to actually think back to the last term, what I did with polynomials, and just divide it. I can't factorize it straight because the factorization won't yield something which gives x minus 1. But I can divide through by x minus 1 if I want. Just for the sake of it, because it's been a while, I'll do it long instead of synthetic. So if I have x minus, if I have x squared plus 2x plus 3, help me out, up the top, x, which means x squared, take away x, 0, 3x, plus 3, up the top, plus 3, 3x minus 3, which leaves me with 6, that's my remainder. So what does the division transformation tell me that I can do with the numerator? I can rewrite it as x minus 1 times x plus 3 with what's left over, right? Plus 6. So I'm going to do that, x minus 1, x plus 3, plus 6. And now I'm in the same boat that I was at this line, right? So you've got that part which is easy to remove. X plus 3. Yep. Plus this part, which is still a fraction. Sorry, I haven't integrated yet. And then you just proceed, just like you did before. X squared on 2 plus 3x plus what? 6 log of absolute value, x minus 1. And there's a constant. Okay? So sometimes you'll see this, right? And you've got to sometimes push on it and see, well, if I can't deal with it with my standard forms now, do I have to break it apart in some way, take advantage of what I remember from polynomials in order to do that? Okay? And partial fractions, like I said, we're going to look at them tomorrow.